move something back and forth at its natural frequency, you transfer or can transfer an awful lot of energy into it. And you see those patterns don't just affect, as I've said, guitar strings, etc., they affect bridges. And what we can also do is we can actually take those patterns and visualize them in a number of ways. So this is a slightly more, much more sophisticated method of visualizing these patterns. And this is something called a Rubens Tube. We have a closed container, so this is a bit like a guitar string. And what we're going to do is we're going to fill this with gas, and we're going to light it. And there's a range of holes along the top here, and what that's going to allow us to do is to see the pattern, to see the wave pattern, to see the standing wave in here. Okay, so all these, this is the gas that's coming out of all these holes. What we're going to do now is Denise is going to set up a wave. And you'll be able to see the pattern of the wave from the flame. This is what physicists get really excited about, believe it or not. We're sort of sad that way. Is when you see the same type of patterns crop up in many, many different situations. And in fact, if you think about what a scientist does, what's the one thing that connects all scientists? The one thing that connects all scientists is that we look for patterns. We look for patterns in mathematics, or we look in patterns for data, we look at patterns for sounds of light. Denise can do something a little bit more interesting. That's a fairly boring signal. Denise can feed in a slightly more interesting signal. And we can transfer the sound energy to energy in terms of the flames. So what you're seeing is the music translated into those patterns of sound, or patterns of flames, and that's telling us what waves are being created within the tube. Wonderful. Let's give Denise a call and some round of applause. We need 8, yeah? Yes. Right. Ready? We need 8 volunteers, right? Ready? Wait for it. Ready? No, your hand, get your hands down. Ready? Down. Not starting until the hands are down. Ready? Steady, go. So, Alex is going to play a little song by turning these people into a human keyboard.
Let's see what we're doing. Okay, I'm going to let's just touch your wrists. There we go. Oh, yours.
Alex, you've broken them.
I haven't broken him.
You've broken them. We're not allowed to break students.
It's because he's holding it. Who's the doctor now? A doctor.
And then... No sound from that. Okay, we've got a few. Let's see. That. Can't do it without seeing.
Oh, hello, we changed the instrument partway through.
Do. Do.
Collapsed. Luckily nobody was killed. Unfortunately apart from a dog which was trapped in a car, and the car fell and we lost the dog. We obviously can't recreate the bridge much as I'd love to, but what we can do is we can show you an experiment. You might have heard of the experiment or the idea where you've got an opera singer who's got a really pure tone to her voice that she can get a wine glass to explode. Have you heard about this? You hit just the right note. That's resonance. That's resonance again. That's because the singer is tuning her voice to the natural frequency of the wine glass. And if she gets it at the natural frequency, she transfers a lot of energy and it will explode. We're going to do the same thing, except we haven't got an opera singer to hand, but we have got Matt and a signal generator. So what he's going to do is he's going to generate a signal. You can hear it already. It's happened already. The glass is gone, but you're not watching the screen. The glass is gone because it exploded, because there was so much energy transfer. It hit just the right frequency, and when it hit just the right frequency, it surprised even me, because that's what remains of our wine glass, because we hit it at just the right frequency. So that's what we can do. That's why we had that problem with the bridge. It's got its own natural frequency. If you pump in energy at that natural frequency, you get disasters like that, or really exciting things like that. Things explode. They take that energy, they want to vibrate at that energy. If you pump in the energy at that frequency, that's what's going to happen. Thank you, Matt. Thank you, Paul. Thank you, Denise. And what Alex and Matt are going to do is levitate something with sound. What they're going to do is they've got a speaker here, and you won't be able to see the wave this time, but there's going to be a wave set up. Can you see that? They're levitating, they're floating, not moving. And the reason is because between where the balls are, there's a wave. It's a sound wave. You can't hear it, but there's what's called an acoustic or sound wave, and that has got peaks and troughs. And what they've done is they've put the balls, they've placed the balls at the place where the wave has got what we call a node. It's the minimum amount of vibration, and it's pinned there. When we turn it off, and they just fall off. It's neat, isn't it? We're going to now make lightning sing. So, what Ian is going to do is use something called a Tesla coil. Doesn't look perhaps that exciting, it does extremely exciting things. So, Ian's going to set it up. And what this generates is about 250,000 volts. So we are going to create lightning in here. Air is usually an insulator. It doesn't transmit electricity, but if you put enough voltage across it, it will. And what you have is the voltage is going to, don't turn it on Ian. The voltage is going to be applied to this really sharp point. And what you're going to see is you're going to see lightning come out the end of this. But better than that, we can control how the lightning is formed. Well, Ian's very clever, and he can control how the lightning's formed, and he can make the lightning sing. By pulsing the lightning, we can have airwaves set up at a particular frequency or a range of different frequencies. Let's get the lights down. That's the reaction I want. As I said, he's a magician, so he can control the frequency. Yes, the resistance. Let's have a round of applause for the Tesla coil.